Let me begin with, and you have been hearing about heat exchanger tubing solutions for long. So now you have become more of an expert after listening to all the experts sitting out here. But despite that, we will try to gain more insights from all these people who are here and see that we add value to whatever you have gained. So my first question to Mr. Venkat Prasad ji and Mr. C.V. Rajulu is the common types of corrosion experience in heat exchangers tube in the pharma and chemical applications, and how do they differ? So Venkat ji, please talk about the chemical part, and Mr. Rajulu ji, if you can talk about the pharma part, because you have an experience of NaCl and Jubilant, mostly chemical. So,
Good afternoon all. So from morning on, all the sessions, most of the types of corrosion, everything is covered. So somewhat whatever I'm speaking is nothing but like a summarizing the entire discussion, or if not, some of the discussion. See, most of the, all pharma and chemical industries, heat exchanger faces a lot of corrosion challenges. There are different types. Means every chemical and every process condition behaves uniquely, and based on that corrosiveness or kinetics of corrosion will change. Basically, we know pitting where the pinholes will form, that will penetrate up to the wall. And we have the stress corrosion where the tensile stress of the tubes as well as our corrosive environment combines together, and the effect will be very catastrophic. We all know that, because any other corrosion will give some signal, but this stress corrosion will never give any signal, and sudden catastrophic kind of thing it will form. Another, we know that fouling, corrosion because of fouling, because of not proper cleaning or in time cleaning, otherwise not taking proper precautions, this fouling also leads for the corrosion. And another one is the important thing is the erosion, where erosion, this erosion precaution we have to take at the design level itself. Because what kind of velocities we have to maintain, what is the tube sizing, by thinking too much on the project cost, sometimes we get into the high velocities, then that will lead for the erosion corrosion. That is another one is the dissimilar metal. Again, it is coming to the cost part it only. We select the SS tubes or noble metal tubes. When it coming to the flanges, we go with MS. So there, because of the dissimilar metals, that will lead for the corrosion of this, what a galvanic corrosion we call. These are the type of different corrosion. So corrosion, what I can say, it is not only the concept of metallurgy or only material selection, it completely depends upon the discipline of the operations and involvement of the experienced people at the design level. That will combat the effect of corrosion in the pharma and chemical industry, I believe.
Thank you, sir. Rajulu ji, your views.
It's my privilege to be here. Thank you for inviting us, inviting me to this conference. This morning it's been very, very learning experience in spite of all these years of experience. Today we learned a lot of things. The great chaps are just beside me. Coming to that, one more point I would like to tell, my safety, because the safety point we have to discuss on. The other day in Hyderabad, where I was staying, I was looking at from my balcony. I just saw one gentleman with his two children on his scooter going in a wrong direction, opposite direction to the, the one way is there, and he's going in the opposite direction with the children, maybe to drop them in school. I almost felt like stopping, but with the traffic around, I could not stop. But if that generation also is being given a wrong impression, wrong guidance, what would happen to the coming generations? Because, one generation takes, culture change takes one generation, that is one decade. So please, all of you, look at the road safety. If the person is not good at road safety, I don't expect him to be safe in the plant. So this is just my observation I would like to share because all young guys are over here. Now coming to the our topic of corrosion. My colleague has already, my co-panelist has already talked about some of the corrosions. But all the corrosions are caused by the only MOC material of construction or our practices is one of the important points we have to note down. In chemical industry, we are not talking about, since morning we are talking about the major industries, a continuous major petrochemicals and fertilizers and all that, where it is a continuous process and a stoppage would lead to a major shutdown and everything is explainable by the cost. But the risk is not covered in many of the costing, the risks will be very huge. One of the experience I tell you, some of the people you might be knowing the Grignard reaction, where THF is reacted with the magnesium and the THF vapor goes into the exchanger where it gets condensed and it comes out into that. As a precautionary, the vapor is condensed at water is higher pressure, a exchanger has leaked out and that water had gone into the THF and this THF is recycled. When it has gone into the reactor with the magnesium, the water reacted and immediately the whole plant got blasted. See, the risks in exchanger looks very small. When you are comparing with the total investment, the exchanger is a very, very small item, but the risks are very high in this. And there is one precaution we do in an engineering. See, make the process fluid pressure is higher than the liquid water pressure, cooling water pressure, so that the cooling water doesn't enter into that, rather let the process fluid, that fluid come into the water, so my process doesn't get affected. In this process, what happens, it has happened. The process fluid had gone into the cooling tower and there was no monitoring on the cooling towers, and this has happened in one of the pharma, I am telling you. And the whole cooling tower had gone fire. And not only that, it had affected the whole plant. So here, the importance of the exchanger is very, very high. And how the quality of the, we have discussed about the MOC today morning. And as rightly Mr. Haribhakti has told, we all are doing the CBM condition-based monitoring we call, and we put a lot of stickers, a lot of measurements are taken. But the correct point where the corrosion happens is not known to many people. In this API 580, 581, which are the guidelines for designing the plant or checking where the failures can occur. That's what Mr. Haribhakti was telling in the morning. The corrosion analysis has to be done loop-wise. Every loop has to be done for the fluid handled, and not only the fluid handled, the temperature differences. Because the temperature can cause the stress corrosion, which you cannot predict and you cannot identify, you cannot monitor also. This is one of the very, very important, the stress corrosions will happen very quickly because of the temperature. At that, this has happened in the distillation column. The temperature goes high, but that material is not suitable at that temperature. The corrosion starts. So these points are very, very important points in a corrosive environment. Another thing is manufacturing. We all take it for manufacturing is taken for granted. Crevice, I have seen the crevice corrosion. What has happened was, it was made in some local workshop or whatever, wherever. What has happened, the diameter of the tube is a bit less than the diameter of the hole on the tube sheet. So it is a welded one. The welding was done. So it is not known. Welding is done, but the cooling water, the sulfates, chlorides and all that, they get settled there. They create the crevice corrosion. this is one of the practical examples we are telling you. And another thing is, in a smaller companies like many of the chemical industries are batch processes. In these batch processes, the exchangers, heat exchangers are commonly used. Whenever the campaign changes, they don't look at that what is the type of heat exchanger he is putting there. Mostly asked what is the heat surface area? Is it available? Suppose I want for heat exchange 35 square meter. Yeah, 55 is there, it's good. It's okay. What happens is, we are not looking at the diameter of the tube, the velocity in the tube. Many of the companies, I am telling you, it's fact, either even some of the pharma, not in bigger names, but smaller companies also, they just see the exchanger, what is the surface area available and put it. But what happens, if the tube's diameter is small, length is bigger, but the diameter is small. What happens? It creates vibrations because of the velocity of the flow, and these vibrations will hit the baffles, and the morning you have displayed. That's one of the reasons.
Now let me come to the next question, which is about the operational issues faced by the industry in different types of heat exchanger, whether it is metallic, graphite, and glass. Pharma industry is moving towards the glass part of it. So in terms of performance, maintenance, and service life, I request Mr. Abhilash Pasham first, and then Mr. C.V. Rajulu. You have to press a bit longer.
I hope I'm audible. Okay. So in terms of metals, graphite and glass-lined heat exchangers. So when we talk about metals, metals are most versatile in terms of we can go for high pressure, high temperatures, and thermal conductivity is also very good. But when it comes to the disadvantages of metal is corrosion. As we've been hearing since morning, we have various kinds of corrosion, whether it is corrosion erosion, stress-related corrosion at the weld joints. So there are a lot of problems in that segment. So how do we overcome that? We've been discussing since morning. And in terms of metals, when we talk about the operation and maintenance. So operation is quite very versatile. You can ramp up the temperature, ramp up suddenly heating, sudden cooling. You don't have much of problems there. Whereas in terms of maintenance, understanding when they fail is a real challenge. And especially cleaning them, the scaling which happens on the metals, cleaning them is another challenge. So these are a little, when I rate all the three materials, that is metals, graphite and glass, I think metals are one of the best ones, but we have the problems of sudden failures because of corrosion, and how do we monitor them? Most of the times, the pharma industry, we do pressure testing once in a while, maybe once in 2 years or and then we feel it is okay. If pressure testing is done, we feel it is okay, but really we need to find a solution to it where we actually should not be ending up with a contamination of the product. So that is one thing. Graphite is amazing thing when it comes to corrosion, especially with hard pH, very low pH or very high pH segments. Graphite is one of the best one, where it overcomes the problems with metals. But the problems with graphite is cleaning. It is brittle, ramping up temperatures, and will not be able to go into high pressures, also high pressure zones. So it is brittle. Even when you're cleaning, there's a problem that we might end up damaging the graphite, and then we don't know, suddenly you just put the pressure up and it breaks. The problem might have been initiated during cleaning. When we are doing the cleaning, there might be some small indentation which will later on cause the crack propagation. So graphite is having that kind of issues. And then we have glass-lined segment, which is almost like graphite. Similarly, we don't we can't ramp up temperatures fast. We cannot go to high pressures. We cannot have cleaning also, and also inspection is a big problem in glass line. We don't know where exactly especially like in tubes where we are just having around 7 tubes or 5 tubes, inspection is very big challenge. So that way I grade metals as one of the best one, but the right selection so that we overcome corrosion, the particular MOC, that is one of the area where we need to look into it. So that I think that is the best solution, I feel.
Mr. Rajulu, any addition to what you were Glass has already.
Yeah, there are 2-3 precautions to be taken. You know, graphite heat exchangers, I feel, is one of the good exchangers. Except for that, the problem is that how these exchangers MOC is very important that we must understand. Not only that, graphite heat exchanger installation is one of the very, very critical point. Normally people say the graphite heat exchanger is cracking at the nozzle or they are damaging, and that's not because of the exchanger manufacturer itself. It is the installation which makes use. All graphite heat exchangers should be supported with bellows, which we normally don't do it. Many companies I've seen, they don't do it because you should have a bellow because they expand and they contract because, you know, whole exchanger is with the graphite. And coming to the metal with I have seen a Teflon coated tubes. You know, it was not very successful. Many people I have seen, many times it has failed and there was a discussion. But, you know, the problem is the temperature difference, coefficient of expansion between the metal to the Teflon. They are not equal. So when the manufacturer designs, if it is such a way that it accommodates both, then there is no problem with the Teflon one. And glass lined is latest has come out because earlier glass lined has got the very bad, it cannot expand. And their conductivity is also very not that good. So even now also the conductivity is not that good, but the exchangers have come with the tubes, glass lined tubes. They are claiming it bit successful, but still there is a long way to go with that. Instead, you know, that is where the question comes whether we have to go to the noble material like Synchro 335 or you go with the glass lined tube. Glass lined is reliability definitely is not that good. You cannot claim the reliability because in petrochemical industries, whenever we go, we study the RAM, reliability, availability, maintainability. That is the first filtration it has to go through. So glass lined may not go through that successfully. So these are all some of the points which we have to remember when we are designing.
Thank you, sir. Ganeshji, if you can throw some light, like say, these fluid temperature, flow rate, chemical composition and pressure. This will definitely lead to corrosion,
Yes.
but how do we minimize it? It's the fact that it will
Yes.
create
So I'll take this question in 2 different parts. Like one is on design aspect and one is on corrosion aspect. So in design aspect, actually, normally what happens is when the exchanger is sized, so we do this thermal design. So where this, flow rate of the fluid and temperature and all other aspects like pressure comes into picture, and you're designing the heat exchanger. The corrosion doesn't comes into picture there. And then down the line, you go with the mechanical design of the heat exchangers, where the code says that if you're using a carbon steel, you give 3 of corrosion allowance. So you give 3 corrosion allowance, and then you do the design. If it is high nickel alloys, there is no requirement of corrosion allowance. You mention it as 0 and you do the design. But is it actually when it is running in a plant or in a site? So there is a lot of corrosion problems in the site. So where this is captured. So it has to be taken care from the initial stage of the design. So that is from a licensor point of view. So licensor has to recommend for this process condition, this material has to be used or something. It has to be structured in a way that it has to be taken from the top. So from licensor down to the end users. So today the ground reality is that the material selection happens either in the licensure stage or after the failure in the site. From the plant people, they do the material replacements. So which is not ideal condition. And in metallurgical aspect, I can say there are two things again. So one is selection of wrong material for the process condition, prescribed process condition. That is one thing. And second thing is your selection of correct proper material, but procurement of wrong material. So that is what we discussed in today's morning session. So how do you procure a right material? See, selection of wrong material for process condition, yes, it ends up in a failure. But after selection of a proper material for a proper process condition, but still there is a failure, that is because of quality of the material which you are buying. So it is everywhere, it is related to, I am just relating this to my presentation which I had today. So it is like, there are multiple things has to be taken care when you are procuring the materials, a quality material to be procured, so that you will not end up in failures in the end customer places. That's my opinion.
Thank you, Ganeshji. Let me come to Shaileshji. I'm trying to, sorry, Pareshji. I'm trying to understand, sir, you have done 9,500 industrial cases. What are the things to do which operation managers or design engineers should do so that they can minimize these and both from a initial point of view when they are installing and on the second when they are running the plant. So if you can say three things which they need to do, it becomes useful for them because some of them have already sunk in the money. They will not go for a new one. Some who are planning for a newer one. So if 3 points in precise for the existing plant and 3 points for the new plant.
Correct. So we start with the existing plant. See, the role of designer does not give you much of the scope because design is already done. So in that aspect, the operation people needs to take lot of understanding about how to operate in a given situation, because you have already given an heat exchanger or you have already given a component or an equipment. Now you have to run it. So first and foremost thing is we need to understand the corrosion protection mechanism. This is all stainless steel. They protect themselves by forming a passive film, that is chromium oxide on the surface. So very serious problem I have observed in these stainless steel components where the passivity is broken. So passivity is broken either by chloride, either by using the base and acidic conditions alternatively. So those kind of situation one should avoid. Second aspect is that the velocity is normally you should keep 3 feet per second of the fluid. If the velocity is reduced by 3 feet per second, then the chances of pitting attack increases. So one velocity aspect is important. And third point, which is preservation. In shutdown, we forget to preserve equipment. So if you don't preserve this equipment, they start developing the pockets of stagnant fluid. The fluid which is there in the operation which remains stagnant comes in contact with oxygen. Also, if the hydro test is done, you left the hydro test water till the next operation occurs. So drying and cleaning takes longer time. So these three aspects, if you can take care, the operation guys, you can improve the life of the existing component and equipment. Now, second aspect is that the plant is making new plant. In fact, the famous book of Perry's handbook is used by chemical engineers to design the different components and plants. Even today people use it, but what I feel is today we have a huge amount of library available on the internet. and what are the damages this equipment can occur. If you can find out in advance, the designer can design wonderful equipment. The problem can be best solved from the design stage. So, as he rightly mentioned, Ganesh, that the right material in a wrong condition, it's a major problem in the industry. People only think that chemical composition is the only correct quality control aspect, which is not right. That's the reason I asked the question, how many of you understand microstructure? So the moment you start defining the microstructure requirement in the design stage itself, the 50% problems will be eliminated from the industry. 50%. And the third aspect, which is very crucial in the design, is that it should give the right inspection windows in the design. Because I have seen many equipment where the designing is made it in such a way that you are left out with only guesswork in the plant. So if these three aspects are taken care from the design stage, I think problems can be eliminated to a great level.
Thank you, sir.
Can I add on something?
Yeah, please.
Okay. One of the important point which Mr. Paresh ji has told, preservation. So this is, I am coming from the defense industry, where preservation is one of very important aspect. Most of the naval ships, we have something called preservation and transportation SOP, which I see missing in most of the other industries. So any equipment which is lying idle for more than 10 days, this is what the defense uses, the term for preservation. After 10 days, if it has not been used, and whether it has been planned to use later or not, we immediately go into preservation mode. So generally the preservation mode is that you flush out all the old fluid, whatever it is there, dry it out with air, and then go for nitrogen filling of that equipment and sealing it. And then after that, we even put pressure gauges and then monitor this nitrogen pressure throughout, whether it is the preservation period or even during the transportation also. If the equipment has been transported from one place to other place, maybe sometimes it will take 3 weeks to transport, 2 weeks to transport. So this is one of the most important thing which I have realized, which makes the equipment, the life of the equipment better. Whereas I've seen in especially pharma industry, we do not have preservation and transportation SOPs. We miss out this, and most of the time we even before installation, we get equipment, we just keep it as lying in the open air. That is one of the major places where it loses its life. So I think that is something which we can add on where Paresh has told. That's a very important point.
Mr. Rajulu, any additions to what he has? If you can
Same
just
thing.
talk about the additions and then to Mr.
Yeah, it is preservation plays a vital role. In power plants, what we do is drain out the water and fill with the DM water and start dosing, continuously monitoring the water. That's one of the very important points, like, different ways of preservation. Very, very important.
So now when we are talking about this design stage, actually management of corrosion should start from the design stage of the heat exchanger, or for that matter any equipment. Since we are talking about here heat exchanger I am talking. So they have touched upon the chemical nature, means what is the chemical compound nature. And one more thing we miss, even when we design the heat exchanger, for that matter any design engineer, they will take the what is the composition is given by the customer. So this is the A is this percentage, B is this percent, C is this percentage. It will add to 99.99, fine, we'll design. But that 0.1 what impurity is, that makes more corrosion effect, which most of the times it will not be considered on the design. That's why in existing plant, whatever the design, instead of copying the old heat exchanger design, whatever the observations we made, that needs to be thoroughly discussed with the designer or the supplier. So impurities makes very this thing. Another one are the fabrication practices. Most of the times we go by L1, that will be L1 only. Because good fabricator has its own, pardon? Yeah. So that's what is the matter. Another one is the, again, project cost. Everybody has, like all of engineers have the project cost pressure on that. But suppose if you go with SS316L, which will reduce 20 to 30% cost when you compare with the duplex steel. So, but duplex steel will give me 2.5 times extra life. That at project life cycle time we have to incorporate in that during capex time as design stages needs to be thoroughly discussed. One more last point I am saying, not only this process where in pharma industry basically where frequent cleaning is required. No? So cleaning agents what we use also needs to be considered in the design phase. Because whatever the process we run different chemicals, when it coming to the cleaning that is completely different nature. So that also sometimes in frequent cleaning cases that also will cause the different kind of corrosion.
Thank you, sir. It was with respect to the proper startup and shutdown procedures which Abhilash ji has already talked about. For startup processes, anything new to be added there, or shutdown you have already talked about?
Yeah. Shutdown I have already talked about. Okay, for startups especially, the same thing, when we are talking about ramping up, ramping down, that is very important. The temperatures, we raise the temperatures gradually and lower the temperatures gradually. That is during the operation. But during startup, okay, one important thing which I wanted to bring out is especially air purging. Air purging is not done, which most of us, we don't have that time also. And sometimes even the equipment doesn't have any purging vents also, air purging vents, which has to be as part of the design. And sometimes, even if the purging vents are there that are not properly there, sometimes it is advisable during installation itself, the equipment is at an angle, slope, so that even in most of the pharma industry, we have this, all the pipelines should be having no dead lags, as well as it should be at a certain slope, so that there is no stagnation of the old liquid. So air purging is one of the most important things. Otherwise, we will, especially with heat exchangers, we will have the problem of air pockets happening, and these air pockets during the process have the tendency to have, to collapse as well as cause pitting corrosion. So the air purging is one of the most important thing, that you gradually fill up the liquid first, purge out the air completely, and then slowly ramp up the temperature and establish the temperature. So that is one important thing which I thought I can share. Startup is okay, and
Yeah, you have already talked about
fine.
the shutdown part of it.
Yeah, thank you.
Thank you. So the challenges which are coming, you heard it from the what we can say the chemical as well as pharma companies. So what innovations are to be done to address these issues, Ganesh?
I think Jyoti, would you want to answer this? Innovations.
All right. So, yeah.
Is it about new metallurgy or as you evolve with the period of time depending upon with different chemicals coming into picture?
Yeah, I think most of the solutions are very simple only. So I would like to start from here. I would like to give a very simple example. The chair that you are sitting on. So if you see, so there is a stainless steel tubing, and there are two plastics that is attached there. If you see carefully, some of them are worn out, and there is a vice corrosion, right? So then sometimes, the solution are near only, and then we should understand first what is the problem. Then next question is the solution and then innovation, right? So then, as we discussed, then sometimes we need to think about the design stage only. So if you have some process media and the temperature, and then you talk about the condition, the pH and all. So then do you have the right metallurgy that is available or not? So if you see, we are thriving mostly on the innovation. So that's the Alleima way. So when we approach customer, so then we ask the problem. In fact, today this event is for that only. We want to get connected. We wanted to understand. So what's your problem? And then, of course, in different industry, they have different sets of problem. And then we'd like to understand, okay, the process media that you use, and then the existing grade that you have. I know the solution is sometimes it's very costly, but sometimes we think the cost only of the material. So that's not always the case. The bigger cost sometimes is the safety. Bigger cost is sometimes the shutdown cost, the $1 million that you lose when you have such a problem. So then, we need to go sometimes. Of course, we'll have to compromise with the cost and all. I know it's a very difficult decision, but you'll have to break the boundary. You'll have to think beyond that. And we always talk about, today also we talk about we have 900 recipe, 900 different grades, and we have 850 or 900 patents. So how we have such, so it's not like, we thought of developing a certain grade. And so these grades, unless until it is not welcomed by the industry, so there is no value of that. And then how we have developed this? So this we have developed in collaboration with the customers like you. So we approached you, we met, and then you discussed the problem. And then we felt that, okay, there's a gap here. Very good example is Sanicro 35, that is our recent grade. So then you have temperature, you have austenitic grades that can work in a wide range of temperature. And then you have corrosivity. So if you add, on y-axis, if your chloride percentage is increasing, so then, austenite will probably not work. And then in certain range, you have duplex, super duplex, duplex family. And then for high temperature and then higher corrosivity, so you have nickel grades. So then there's a big gap that we found that, and that gap is filled by Sanicro 35. So then, so, and then this is only became possible when we talk to you. So, yes. So Ganesh, would like to add something here?
Yes, see, typically, before finding the solution, let me throw a light on, the time for failures. So different corrosions we speak about. So the time for failure, like if it is a uniform corrosion, it may take a couple of years for failure. If it is pitting corrosion, it is a couple of months. And when it comes to stress corrosion cracking, it is a couple of hours. So after a couple of hours of installation, you see failures. So recently we are doing a study on one of the failures which happened. So I want to share that. So it is like, it's like a very dilute acid with high temperatures. So they used a 316L tube there, and he was explaining me that it was a tube of 16 mm thickness. It's not a tube, you can say it as a pipe. So it is of 16 mm thickness, and within 4 hours of operation, the thickness has dropped to 4 mm. So almost 12 mm of thickness has been reduced within 4 hours of operation. So it is like, then we had a discussion, who have selected this metallurgy? So the answer came like, so with our previous experience, yeah, it is like, yeah, we have taken that, considered that this would be, a perfect material for this application. So it is not right every time. So we have to take suggestions from material experts and industry experts who have, faced these kind of problems. So it's like, to add to what Jyoti said, so it is not only on failures. Like we have to understand the problem, and then you have to take the suggestions from a couple of people, like material experts and industry experts, and then you have to decide which is the right material for this prescribed process conditions.
So we have one last point which we need to cover, which is root cause analysis will help in preventing corrosion and how it can be done by pharma and chemical industry. So anyway, that will be...
Before we close, one
Yes,
small.
sure, sir.
We have talked about everything but not cooling water right now. Cooling water plays a vital, very, very important role because the chlorides, sulfates, hardness, TDS. I know that a lot of people are trying different technologies are coming now to increase the TDS to the 30,000, 40,000 also. And they are saying that it is very good, nothing is happening because they are in the ionized state. But it is not the same for the heat exchanger. All these TDS and all that, whichever is the form, they create some erosion effects on the cooling tower, exchanger tubes. At the same time, some chloride effects will keep on going up and they will definitely affect the exchangers. But I came across some of the developments on changing the cooling tower, cooling water, chemistry. So this maybe you have to look at it very carefully. Cooling water plays a very, very important role in the corrosion of the heat exchangers as well.